Hello friends, we just witnessed spells of unprecedented heavy rainfalls in whole of Bharat during end September and early October 2022. The rainfall moved quickly over from deficit to about 7% plus from annual averages in a matter of 3 odd days. Such an occurrence almost squarely coincided with closest transit of Jupiter with Earth after 59 years, which occurred last time in the year 1963. On 26 September, Jupiter was 39% closer at about 590 million kilometers as against its farthest at 960 million. Most weather agencies repeatedly had to revise withdrawal of monsoon dates beyond their earlier estimates for 2022. Though, however, none of them could find a link with the close transit of Jupiter, as did our research. Watch YT6 in two parts to discern the same. For future, also remember our year 2022 global weather forecast of precipitation abnormally extending beyond September and early onset of winters. Do also realize that it is the astronomical influences which majorly regulate Earth climate rather than El Nino and La Nina, which are misbelieved to be the sole global weather determiners by weather agencies the world over. In our previous video YT5, we had discussed how position of gravitational and electromagnetic giant Jupiter in its orbit around the Sun influences Earth's sun distance, deviating much from its regular orbit estimations during any given time of the year. We had also indicated that changes in the Earth's sun distance and distortions of Earth orbit would influence the global Earth weather in erratic and unforeseeable ways. Yet, without taking the same into consideration and instead on the basis of El Nino and La Nina as well as the statistical analysis, the World Meteorological Organization in its report dated May 9, 2022 has forecast a rise of 1.5 degree over the 20th century average of 15.6 degrees centigrade in at least one out of the 5 years 2022 to 2026. Is placement of Jupiter really I care a damn kind of stuff for Earth climate? What especially stands ignored in the said forecast is the influences exerted by forthcoming closest placement of Jupiter with Earth on 26 September 2022. Jupiter would be just about 584 million kilometers away from the Earth, as against its farthest placement at 960 millions. This would surely have gravitational implications in the planetary game of push and pull, as a consequence of which the Earth's sun distance is going to deviate from its usual and regular estimates at this point of time, now occurring just 3 days from the autumn equinox. There is not a single factor in the interconnected cosmos that could have exclusive domain of influences to the exclusion of all others. The distortions originating from irregular Earth orbit change the heat source Sun and sink Earth distances and angles at any given time. However, the same couldn't influence the Earth climate in simple and straight proportions. Earth's atmosphere acts as a potent filter. It effectively buffers the incoming solar radiations in such a manner that through its day-night and seasonal postures, strong radiations encounter more resistance and the weaker ones lesser. It is through the complex structure and characteristics of the atmosphere that life on Earth goes unscratched despite repetitive solar magnetic and other storms, flares and coronal mass ejections. The complex Earth atmosphere and how it functions is a very elaborate topic and would be subject matter of a separate YouTube video by us. It is only in the last 100 plus years that global weather has witnessed proper data record being maintained. The alarms and blips in the heavily buffered Earth climate are the revealing lookout points. Our own original research could detect overwhelming connections between the climatic spikes and extreme placement combinations of Jupiter, Saturn, Moon and Sun with respect to the Earth. Each year at autumn equinox on 23rd September, sun rays fall nearly direct on the northern hemisphere as it migrates from summer to the winter alignment. With near equal days and nights, September averages are a good sample case for studying Earth climate. Northern hemisphere, being Earth predominant, is a better significator and responsive to the solar influx and reflections as compared to the southern hemisphere, which comprises more oceans than land. Though, however, the northern is more susceptible to human activity related influences, which also impact how solar radiations get filtered, reflected and retained on the Earth. Yes, the hint is about greenhouse gases, ozone layer, cloud cover and precipitation. Southern hemisphere with scantier human activity accords serene and uninterrupted playfield for nature. In many ways, September is a good time of the year to study cosmic impacts in the northern hemisphere and March in the southern. September 2016 was the hottest ever September since 1910 for Europe and Asia, third hottest in North America and generally hotter in other places, with Arctic sea ice cover falling below 27.8% as compared to the years 1981 to year 2010. During September mid to October mid, Sun occupies the constellation Virgo as seen from the Earth. In September 2016, Jupiter also aligned in Virgo much farther behind the Sun. Their combined and aligned gravitational pull had drawn the Earth closer to the Sun in the direction of Virgo, enhancing the influx of thermal radiations, resulting in one of the hottest September in the parts of northern hemisphere. Though some of it would have got mitigated due to the Sun's rotation and its wobble owing to the gravitational pull of Jupiter close behind, as already discussed in our video YT5. Even the southern hemisphere witnessed unusual heat, with Africa encountering second hottest September since 1910 and Antarctic reducing ice cover to its fifth lowest ever. How do the Earth and its atmosphere respond when exposed to the enhanced solar radiations? Exosphere, the outermost layer of the atmosphere that begins around 700 kilometers from the Earth's surface, expands and contracts in response to the solar radiations. At times, the solar storms shrink its usual active sun expanse of 10,000 kilometers above the Earth's surface to 1/10, that is just about 1,000 kilometers. Exosphere is really not much different from space, as both are characterized by utterly low gas ions density. Exosphere is very close to vacuum state, which we all know is a great heat insulator. As laymen, we experience the said property of vacuum used in the day-to-day lives in vacuum flasks which keep the contents warm. Stronger the radiations, more is the shrinkage in the exosphere, with similar reduction in its vacuum potency and ultimately the thermal insulation capabilities. With more and more shrinkage in the exosphere, more heat gets its way into the Earth atmosphere at a higher than usual rate. The Western science has not yet addressed this aspect, as also whether increased solar wind pressure, which causes the active sun side to compress, also causes the night side of the Earth atmosphere or the magneto-tail side to extend farther in corresponding proportions. Increased solar radiations bring along enhanced influx of higher energy waves and particles into the magnetosphere bow area. The night side of the atmosphere also expands in unknown proportions. Behavior, characteristics, and attributes of an air column change not only with changes in the compositional mass but also with its volume, density, pressure, and temperature. Gaseous state of matter alters much with the fluctuations in pressure and temperature. The area expansion of the heat escape ways, that is the night side exosphere portion, converts into an enhanced level of vacuum that ultimately poses higher degree of insulation and stronger barriers for release of heat trapped in the Earth atmosphere. The Earth atmosphere thus encounters a vicious cycle causing retention of more than usual heat. This process disturbs the overall thermal equilibrium of the Earth for the given reason and durations due to the cosmic reasons, though of course compounded by human activities enhancing greenhouse gases, adding insulation to the trapped heat in the lower Earth atmosphere. We end part 1 of the topic here and would continue the discussion in part 2.